Hello everybody, I am back with another video. Today we will be discussing gravitation. Newton's law of gravitation is the law that describes the forces that act between different masses in the universe. Everything is bound by gravitation. The moon is bound to the earth because of gravitational force. The earth is bound to the sun because of gravitational force. The sun is bound to the galaxy because of the gravitational force. So it makes it extremely important for us to understand and appreciate this force. Let's begin. Newton's law makes a very strong statement, and the statement goes this way: every body in the universe attracts every other body with a force that is directly proportional to product of magnitude of the two masses and is inversely proportional to the square of the distance between their centers. And the force acts along the line joining the two centers. Now, how to understand this statement is what we are going to work on. Let's begin. Let's assume that we have two masses here. That's mass number 1, and here that's mass number 2. We have m1 and m2. The distance between them, let's say, is r. Then the proportionality would happen this way: the force between the two masses, this will experience a force in this direction, this will experience a force in this direction, and these two forces are going to be equal, always equal, as a result of Newton's third law. Okay, now having said that, we have force being proportional to product of the two masses and is inversely proportional to square of the distance between them. That means if you double the distance, the force between them becomes 1/4, and if you halve the distance, then the force between them quadruples, and that's the kind of relation they have. Now, in order to make this an equation, you put a proportionality constant. That's a very beautiful proportionality constant, something very basic to the very universe. And if you end up changing this decimal, this gravitational constant, even by a very tiny amount, universe wouldn't exist the way it does today. So that's how important a constant this is for the working universe that you have. Well, the value of gravitational constant, capital G, is 6.67 into 10 to the power of minus 11. You can just work out the units. It would be Newton meter square per kg square. That's the unit, by the way, and you can use this in different kg square. Yes, and you can use this in different formulae that you calculate. In almost all the formulae involving gravitation, this G is going to be present. So we have to be a little careful about remembering its value. Having said that, and having shared that with you, we will now ask a very fundamental question. CRS, now you said that these two forces are equal. Let me call this F12, which means force acting on the first mass due to the second mass. And this is F21, which is the force acting on the second mass due to the first mass. If you want to make an equation out of these vectors, then you would write it this way. Force acting on the first body due to the second body is always equal and opposite to the force acting on the second body due to the first body. That's how you should learn that. And that's what it essentially means. Having said that, you must ask me, when this law is true, earth attracts me and I attract the earth. When this is the situation, if both of these forces are equal, because earth is really big and I am really small, if these forces are equal, why do I always fall onto the surface of the earth? Earth doesn't fall onto me. Dear friends, forces does not mean movements. Force means a push or a pull. The amount of force that you experience towards the earth, the amount of pull that earth applies on you towards it, is the same pull that you apply on the earth towards you. But earth is so massive that it is unmovable. You are so tiny, you are really small, and that's the reason why the same force accelerates you by a lot, and the earth being almost infinite when compared to your mass, its acceleration is 0, so it doesn't come towards you. So having this understanding in our head, we will assume that every other mass that we are going to talk about is so small when compared to the mass of the earth that the earth is always unmoving. Having said that, let's continue and try and understand the first question that I've got for you. All of these questions are from various competitive exams, and it's important for us to do these questions. These questions in this lecture are quite simple to handle. So let's begin with something simple, and as and when we go to the next and the next video, we can increase the level of complexity so that you get very comfortable solving each question. So follow these videos carefully and make sure you like and subscribe so that you get my next video on time. Let's begin. The question says two identical copper spheres of radius r are placed in contact with each other. The gravitational attraction between them is proportional to. That's the question to you. Let's draw out two copper spheres. Here is the first copper sphere. Let me make it look a little copper, and that's a copper sphere. I have another identical copper sphere, so let me place it here, and the question says that both of these are in contact. So put them in contact. Well, now the distance between them automatically becomes 2r. So this is the distance between them, because the radius here is r and the radius of this is r. The distance between the two centers, by the way, the distance between the two centers automatically becomes 2r. When that is the situation, we are supposed to calculate the force between them. You would be tempted to say that from Newton's law of gravitation, you have F equal to G. Mass of the first sphere is m. The mass of this sphere also is m. So you would write m1 into m2, which is m into m square, divided by 2r, because that's the distance between their centers, the whole square. That's the law of gravitation. G m1 m2 divided by r square. R is the distance between the two centers. You would be right if the question had said two copper spheres of mass m and radius r. This is the trick in the competitive exam. You must answer in terms of the quantities given in the question and not anything else. So if you wrote that, okay sir, everything else is a constant, you have g m square divided by 4r square. Looking at these options, I have f inversely proportional to r square. If you took option, if you ticked option B, you're going to be wrong, because the question does not say mass m. So your answer must not be expressed in terms of m, it must be in terms of r. If there is anything else in your equation, they must all be constants. So let's put the effort. Well, of course, from here, you can start writing proportionalities, because the question says is proportional to. Well, the mass of the copper sphere can be expressed in terms of its density and volume. And you know that volume of a sphere is 4 divided by 3 pi r cube. That's what is the volume of a sphere given by. Now, you have an m square there. So m square would be proportional to, all of these are constants because both of these are copper spheres. So rho is a constant for both of them. It doesn't change. It's density. Both of them are copper. 4 by 3 pi are anyway constant by nature. So we have r power 6. M square is proportional to r power 6. And then there is a r square in the denominator. 4 is anyway a constant. So if you wrote down f is proportional to m square, and m square is proportional to r power 6 divided by f is also proportional to 1 by r square. You can write r square in the denominator. So f becomes proportional to r to the power of 4. So this is option C. You tick option C and then go ahead. So you have to be this careful. What is seemingly simple can have a challenge for you. This is not a very big challenge, but then this lures you into making a mistake. So one must be careful, must read the question. Let's go further to the next question. Two particles of equal masses, the question says, go around in a circle of radius r under the action of their mutual gravitational attraction. So there are two masses, and the two masses are going around each other. Now this is a system called binary system, right? Well, if you watch a photo album or a live wedding of a South Indian guy or a girl, you will see that the pair is asked to look at the night sky, asked to look at in the northern direction. The priest asks them to look in the northern direction. They are actually looking at a binary called Mizar, and this binary is supposed to tell them that they must be bound to one another emotionally, like how these two stars are bound to each other gravitationally forever. So that's a symbolic way of telling them how to lead a life. But anyway, this is a binary. This is a binary. So let's talk about what a binary is. We have two particles. So I have the first particle here, and then if I have another particle, let's say this is the first particle, be a different color, and the same kind of particle once again, same kind of particle, and these two particles are going in circles. These two particles are going in circles around each other, something like this. So they are going in circles, right? Okay. Now you can just say that this is experiencing a gravitational force in that direction, and this is experiencing a gravitational force in this direction. But we need to understand that the distance between them is certainly the diameter of this circle, and that is 2r. The distance between the two masses is 2r. But they are going round in a circle of radius r. We must not forget that as well. For anything to go around in a circle, we have been asked to calculate the speed of each particle. So how fast is this particle moving? That's the question to you. If you were to answer that question, then you need to know that any particle that's going around in a circle must be experiencing a centripetal force. So the mass here is m, this is also m. These masses are experiencing a centripetal force because of mutual gravitational attraction. So we have the gravitational force providing the centripetal force. mv square by r is the centripetal force. Maybe I should have written capital R because that's the notation I've been using. mv square divided by capital R. It's equal to g m1 m2, m1 into m2 is m into m, that becomes m square, divided by 2r, because that's the distance between them, the whole square. mv square by r is the centripetal force that is being provided by the gravitational force of attraction between the two, and gravitational force of attraction is g m1 into m2 divided by distance square. The centripetal force is given by mv square times r. R is the radius of the circle in which the mass is going around. So we have one m and the other getting cancelled. Well, we have v square divided by r being equal to g m divided by 4r square. Square and r gets cancelled. So we have v equal to, if I take a root of gm divided by 4r is what you have. Root of 4 is 2. So you can write the velocity v as 1 by 2 times root of gm divided by r. 1 by 2 times gm by r. And that is option C. That's how you get to the answer. So this was the second question that I had got for you. Seemingly simple, but then if you understand this, you can apply this same concept in any question which involves circular motion. Let's go further to the next question. A mass capital M is divided into two parts, xm and 1 minus xm. So there is a mass, right? We have, let's say, a mass. Well, something like this. You've got a mass. And then the question asks you to split it up into two parts. One part is going to be mxm, the other part is going to be 1 minus x multiplied by m. Obviously, x is a number less than 1. It's a fraction, it's a proper fraction. So x is less than 1. When that is the case, if this xm, the fragment, the mass, if you go on changing the value of x, if this fragment increases in mass, then this fragment decreases in mass, such that if both of these are added, you always get the same total mass, capital M. So capital M is the total mass of the body that we are talking about. And if you split up, you get two parts. The first part weighs xm, the second part weighs 1 minus xm. X is a fraction. If x is half, then you have divided the the body into two halves. So that's what it essentially means. Having understood the question now, I mean, of course, the statement, one part of the statement of the question, the value of x for which the gravitational attraction between the two pieces becomes maximum is. So what should be the value of x so that the attraction between the two becomes maximum due to gravitation? That's the question. The same kind of question can occur for two charges, because the force between two point charges follows almost the same trend. So the explanation is a lot similar that I would give you for charges in gravitation. Both of them are absolutely very, very similar. So let's go further and talk about it. Anyway, having understood the question now, let's answer the question logically, which is very, very important. Let's answer the question logically, because I don't want you to solve this question in the exam or do the integration, differentiation stuff and get into calculus, and because this is not just one kind of a question. So I would like you to know the logic. The logic is, well, let's say I have this particular mass. I have this particular mass. And the mass has been split into two fragments. Let me call that mass m1 and the second fragment m2. Let's say the total mass of this thing is 10 kg. If m1 is 10 kg, then m2 must be equal to 0, right? If the m1 is the whole, then there is nothing remaining for m2 to be. If m1 is 9 kg, this would be 8. If this is 8, I'm so sorry, this is going to be 1. And if this is 8, this is going to be 2. If this is 7, 3. And if this is 6, it would be 4. If this is 5, that would be 5. The reason why I'm writing this, it could look very trivial, but then I want to convey a message. The force between the two fragments when they are separated depends on the product of the two masses. So because it depends on the product of the two, 10 into 0 would give you a 0, 9 into 1 would give you 9, and 8 into 2 would give you 16. And in case, let's say, okay, and let's say you have f, 8 into 2 would give you 16, 7 into 3, 21, 6 into 4, 24, 5 into 5 would give you 25, 5 into 5 would give you 25. That means the force has become maximum when these two are equal. That means m1 and m2 are equally heavy. So the fragments must be equally heavy for the force to be maximum between them. When that is the situation, what should be the value of x is the question. So what should be the value of x? If one fragment has to be 1/2 of the total mass, 1/2 of the total mass is what we are talking about. So it's quite obvious that x is 1/2. X is 1/2. This is how you would do it logically. But then if you come up and tell me, CRS, I think this is a very logical thing. We are doing physics. We must be mathematically consistent, and we have to be very prudent with respect to our method. So let's do a general method. Let's do a general method of solving this. Let's go to general method of solving this question. Well, you see, if you plot a graph of force between the two fragments, so that's fragment number 1 and this is fragment number 2, they are separated by a certain distance. The mass of this fragment is x into m, and the mass of this fragment is 1 minus x into m. The force between them is F. Now, if you ask me, CRS, what is the force between them? Force between them is G multiplied by, maybe I'll just write it here. The force between them is F equal to G. M1 is x into m. M2 is 1 minus x into m divided by the distance between them is r, and you have to square that. That's the force between them. If you change the x, you will have the force changing. So F is a function of x now. X is the fraction of one of the fragments. There are two fragments, one full mass capital M, two fragments. One fragment is xm heavy, the other one is 1 minus x into m. So this force is now a function of x. So if you plot a graph of, let's say, okay, if you plot a graph of f and x, you will have a graph like this. You will have a graph like this. For x equal to 0, you will get force equal to 0. You go on increasing the value of x and the force goes on increasing. At some point, the force becomes maximum. And at that point, you need to see that the slope of the graph is equal to 0. The slope of the graph in this case is df by dx, because y, on the y-axis there is a force and on the x-axis there is x. Dy by dx is slope and df by dx is the slope for this graph, and at the maximum point df by dx becomes 0. Using this concept, you can find df by dx and then equate it to 0. Let me reform this equation. If I wrote df divided by dx, you would have g, I'm sorry for writing pathetic g, okay, g m square divided by r square, which are all constants, and then inside the operator you have d by dx of x multiplied by 1 minus x. You will have to differentiate this. If you differentiate this, you will have df by dx equal to g m square divided by r square multiplied by, how do you differentiate this? It's just product rule. So first function, differentiate the, first part of the function, differentiate the second part of the function. Differentiation of 1 is 0, differentiation of x with respect to x is 1. So you have this plus the second function as it is, second part of the function as it is, multiplied by differentiation of the first one. So you get 1. The next step that we've got to do is to equate the right hand side to 0. When you equate the right hand side to 0, you will have 0 equal to gm by r square can be sent to this side, it will automatically become 0. You will have minus x plus 1 minus x is all that you will have. Bring both the x's to this side, you will have 2x equal to plus 1 or x equal to 1 divided by 2. Exactly the same answer that you had in the first case. I had already ticked for you, so let me tick that again. It could be logically or be it mathematically, you will arrive at the same answer. This is the understanding behind why you would differentiate to get the answer. It's to find the slope, and slope at the maximum is 0. You will also have to know that the slope at the minimum also is 0. That's the question I leave you with. How do you figure out whether a certain curve, when you differentiate a certain thing and you equate it to 0, you're referring to either a maximum or a minimum? How do you know that it is a maximum or it's a minimum? That's a question for you to think about. Remember, the day you stop growing is the day you start decaying. Thank you so much.